So the class is being recorded now. So we'll be talking about linear programming. Linear programming is an extension of single limiting factor. But before we go ahead, I would just want someone to give a brief summary of what limiting factor is all about, based on your understanding on the various assignments that you've solved. Can you give a brief summary of limiting factor? Because you'll be writing these in the exams, so you should be able to teach me what limiting factor is at this point. So can I get volunteers? Can you just raise up your hand if you want to say something about that limiting factor? And if you will not raise up your hand, I'll call your names. All right, Mr. Babajide.
Okay, sir. Thank you. So, in my layman understanding, limiting factor is that resource that has the potential of not making an organization to achieve its goal. So it could be time, it could be materials, it could be so it could be time, that is labor hours, it could be materials, it could be demand. So that's what I understand by limiting factor. Thank you, sir.
Yes, sir. You are no longer a layman, sir, by the virtue of being in this class. Mr. Babajide. You are no longer a layman. So, as an accountant, you are faced with problems of limitation of resources, limited resources in your organization. What are possible solutions you can proffer to your organization? Madam Ruth, let me hear your voice. Hope you are not on Lagos traffic. Yes. Madam Ruth, can you hear me?
Hello, sir. Good evening, sir.
Good evening, ma. Yes.
I was not with my phone.
Yes, you don't need to be with your book, ma.
Like my phone.
Your phone, better. So, what can you tell us about when you have a practical scenario now on the need for you to proffer solutions on certain limitation of resources, limited resources in an organization? What are the steps based on what you've learned?
Okay, number one, first we test for the limiting factor. Then the second step, we calculate the contribution per unit. Then from there, we calculate for the contribution per limiting factor. Then we rank. After ranking, we allocate. After allocation, if the question say we should determine the
Special order.
the profit, and if there is special order, we allocate to those to the special order first before considering others. Then after that, we determine the profit.
All right, thank you very much for that. Sorry, I'm still in the office, so you'll be hearing some little noise. Sorry about that. Yes. So thank you for your contribution, Mr. Babajide and Madam Ruth. So tonight the subject matter will be on linear programming. Linear programming was not tested last night. So this should be a pointer that everything about linear programming, no, is not a very complex topic per se. Once you give your mind to it, yes, it was not tested last diet. So I'm expecting it this diet, May 2026. So I'm expecting it. So do all you can. Don't see it as something ambiguous. It's simple follow the steps, and you'll be fine. So when we talk about linear programming, what are we talking about? Yes, in advanced nation, they don't do linear programming on paper again. They use softwares, they use computer to analyze issues that have to do with linear programming. As a matter of fact, if you check ACCA syllabus, you even see the the write-up on how it is being done using computer. Yes, but in our settings, because they use computer to even write their exams there. So, but in our settings, we still use the manual method to try to make known what linear programming is all about. So when we talk about linear programming is a quantitative decision-making technique used to determine the best possible outcome. Used to determine the best possible outcome, subject to what? Limited resources. Subject to limited resources. So linear programming is used when you have more than one uh, limiting factor. When you have limiting factor in terms of skilled labor, unskilled labor, you have limiting factor in terms of materials. So when you have more than one uh, limitation, one limiting factor in an organization, you use linear programming to address that problem. And there are various steps you need to note when solving linear programming question, when solving linear programming questions. So, but the point is, why linear programming? Why does organization make use of linear programming in solving problems that have to do with limited resources? For them to be able to allocate those scarce resources effectively in order to maximize contribution, So over time, we've laid emphasis on the word contribution, because as you study for performance management, the word contribution will keep coming. And we said contribution is what? Selling price less variable cost. In another way around, contribution can be what? Fixed cost plus profit. Fixed cost plus profit, just as we've seen in limiting factor, So based on what I have in my slide, I said limiting factor, linear programming may be described as a mathematical modeling approach designed specifically to allocate the available limited resources of an organization among the various competing product line in order to achieve the economic objective of the organization under a multiple constraint situation. So that is a limiting factor. So some questions can look as if is a single limiting factor, but as we read and test for limitation and confirm if there is limiting factor in question, you discover that there are questions that are meant for linear programming. So that is why the first step in solving limiting factor is very important, to confirm limitation, So as I've said, that this limiting factor or linear programming represents an extension of the optimal product mix decision, especially where two or more resources of the organization are limited in supply. For example, in an organization where you have only 1,000 kilograms of raw material and 2,000 direct labor hours and 1,500 hours of processing time are available on weekly basis. In this scenario, you can discover that this organization is faced with more than one limiting factor. Hence, the concept of linear programming will set in. So the key elements in linear programming, there are certain elements you must note when trying to solve linear programming questions. You will definitely have the unknowns, decision variables. These decision variables are the unknowns, the unknown variables, whose values you want to determine. So for example, to solve linear programming question, you will need to formulate inequalities. These inequalities consist of unknown variables and consist of known variables. So it is the unknown variables that you solve for. For example, you have issues of X and Y. You have issues of A and B, depending on how you want to define the variables. So as you solve, you're trying to determine these unknown variables. So for you to determine these unknown variables, you must first of all define your objective function. Your objective function. And what make up your objective function? Your objective function is, are you trying to maximize contribution? Are you trying to maximize output? Or you are trying to minimize cost? We maximize profit, but what we do, we minimize cost. We minimize cost. So questions can come in diverse ways. So when you solve and you have contribution, a positive value of contribution, it shows that you are to maximize contribution. For example, when selling price less variable costs is giving you contribution, positive value, it shows that you have to maximize contribution. So based on this, the objective function. And the objective function can either be to maximize contribution or to minimize cost. When you are solving a question that involves maximization of contribution, all what you're doing when you are maximizing contribution, you do the reverse when you are minimizing cost. So for you to solve linear programming question, once you identify the objective function, the next thing you have to do is to what? Is to come up with constraints. You identify the various constraints that may limit the attainment of the established targets of the organization. So once you identify your constraints, what are those constraints? There are those limitations. And I said when we are treating limiting factor that there are certain words, synonyms, that the examiner will use. And when they use such words, you actually know that these are the limiting factor. For example, they will tell you the maximum material available, that the material available is limited to, that the quantity of labor, of skilled labor available is 25,000 hours. These and that, all these words can be used to show that these are the limiting or the limited resources. So once you identify the various constraints, the next you have to do is to express each of these constraints in the form of inequalities. Now, when we talk about inequalities, what are those things we have to see in inequality? Can I get a response? Talking about inequality, what are those things that make up an inequality? Yeah, can I get a response?
Greater than or equal.
Yes, greater than or equal to. Now, if something is greater than, how will you know? So the point is this: an inequality indicates a restriction or limitation. So it does not show the exact value of a thing. Yes, that is inequality. So in inequality, you can have less than or equal to, greater than or equal to, or strictly less than or strictly greater than. So in linear programming, constraints are usually expressed as inequalities because resources are limited. So you express each of these constraints in the form of inequality. So once you express each of these constraints in form of inequality, what will you do next? You come up with the concept of non-negativity. Now, let me still dwell on point 3. To express constraint in form of inequality, it shows that if you need 1 unit of skilled labor and you need 2 units of unskilled labor to produce product A, and product A will use a maximum of, let's say, 20,000 labor hours. When you are expressing this in form of inequality, it will be 2A plus 2B less than or equal to 20,000, because you cannot have labor hours above what is available. So it will always be less than or equal to the maximum given to you in the question. So once you can express that inequality, the next thing you have to do is to establish the concept of non-negativity. And when we talk about non-negativity, it means that you cannot produce zero, or you cannot produce -1 goods. It means when you are producing, you cannot produce a negative good. You can either not produce, that is, you can have zero production, you can have production of 1 unit, you can have production of 2 units, you can have production of 3 units, but you cannot have a production of -1. You cannot have a production of what? -2. You cannot have a production of -3. So the concept of non-negativity is a basic condition in linear programming, which states that decision variables cannot take negative values. So you cannot produce a negative quantity. You cannot use negative labor hours or consume negative material. So that is the concept of non-negativity. So it's just a simple expression of saying that X is greater or equal to what? 1. So it means that you cannot have 0, or X is greater than or equal to what? 0. That is the expression of non-negativity. X is greater than or equal to, or if it is Y is greater than or equal to what? Equal to 0. So you cannot have anything below 0. Below 0. So that is the concept of non-negativity. Non-negativity. Now, some question we just want you to stop at that point. They will just tell you, show the linear, formulate a linear equation or formulate a linear programming equation. But some question we want you to go further. And when some questions want you to go further, it means you have to convert the inequality into an equal sign, into a simple equation. When you convert the inequality into equation, what will change? The equation sign, the inequality sign rather, will change to what? Equal sign. The inequality will change to what? Equal sign. So instead of having less than or equal to, it will now be what? Equal to. Equal to. So when the inequality change to simple equation, then you can now find the unknown variables. So when you have 2a plus 2b equal to 300, you can easily find the value of a by making b 0. So when you make b 0, anything multiplied by 0 will be 0. You will now be left with 2a equal to, let's say, 20,000. So you can now divide 2 by both sides of the equation. You will be left with a and get the value of a. So if you want to get the value of b likewise, you can make a to be 0. Anything multiplied by 0 will be 0. Then you can now have b standing alone. So you divide both sides by the variable associated with b on both sides of the equation to get the value of b. So once you do that, you can now solve the linear equation and identify the associated linear values. And this will lead you to plotting graphs. Yes, you can express the values of the known values on a graph. You can have the x-axis and the y-axis. Then you plot a graph. When you plot a graph, you can also identify the visible region in the graph. That is the area where you can, the visible region is the region on the graph where you can find constraints, the region that is bounded by the constraints. That is the visible region. Any region outside that visible region, it shows that there is excess of resources. to meet up with the demand. So the visible region is the set of all possible solutions to a linear programming problem that satisfy all constraints, including the non-negativity conditions. So this visible region, it is the area where all restrictions overlap, yes, intersect, and within which a valid solution must lie. That is the visible region. So most times you see students trying to determine where the visible region is on a graph. If you check, I think May 2024, 2025, yes, there's a question on linear programming, though it's a repeated question, which was tested in 2024, if I'm not mistaken, was repeated again in 2025. So that question requires students to plot a graph and identify the visible region. Yes, every diet, you always see students coming to ask, but I'm plotting the graph. I'm not getting the visible region. I can't identify the visible region. So one of the objectives of this class is to make sure that every one of us can identify the visible region and be able to solve linear programming questions with ease without any much headache. So once you plot your graph, once you plot your graph, still using your graph, you can have a solution table where you can identify at what point on the graph will you have the highest contribution. The highest contribution. So at what point on the graph will you have the highest contribution? And this can be achieved by using the objective function you formulated at first in the question. So these are the steps to solve linear programming question. These are the steps to solve linear programming question. So we'll start with not too complex questions as it relates to linear programming. Let me see if I have a simple example to illustrate this. To illustrate this, let me start with something complex. If I have a simple one, illustrate this. Okay, let me see. All right, let's start with this. Let's start with this. Start with this. So any question regarding the various steps before we read these out? Any questions? There's no question. Somebody should read it. Can somebody read, please?
All right, let me read it. It says the following information is in respect of three products, A, B, and C, manufactured by a company. And then it's classified here per unit, selling price for A 75, B 60, and then C 80. Then cost broken down into direct material cost 24, 27, 36, direct labor 15, 20, and 30, and then fixed overhead costs at 160% of labor costs 24, 32, and 48. All workers are paid at the rate of 2 naira 50 kobo per hour. All products use the same type of raw material, which costs 3 naira per kg. During this year, the company can procure a maximum of 12,000 kg of raw materials only and has facilities to employ only 8,000 labor hours. The company wants to introduce linear programming technique to ensure judicious allocation of the limited resources required. Make necessary calculations and formulate the linear programming objective function and constraints to maximize the company's contribution margin. Thank you.
All right, thank you very much, sir. Yes. Looking at this question, we have three products, product A, B, and C. We have the selling price for each of the products given. We have the various forms of costs associated with the production of these materials, of these products, A, B, and C. We have direct material, direct labor, and fixed overhead, 160% of labor cost. Fixed overhead, 160% of labor cost. So now I highlighted some of these words in red just to point home or to buttress certain things in the question. You look at that all workers are paid at a rate of what 2.50 kobo per hour. So if you are a worker and you work for 2 hours, how much will you get? It will be 2 multiplied by 2.50 kobo, because 1 hour labor rate is what? 2.50 kobo. So all products use the same type of raw material, which costs 3 naira per kg. You can see they are giving you the cost per kg, because when formulating the linear programming, you use this element of cost per unit, per kg, to formulate your inequality. So during this year, the company can procure a maximum. It shows that the limit to the raw material they can procure is what? Is 12,000 kg. 12,000 kg of raw material. They cannot go beyond that. They cannot go beyond that. So you don't need anybody to tell you the maximum they can procure in terms of raw material is 12,000 kg, and has facility to employ only. It means that they cannot employ labor beyond what? 8,000 hours. Beyond 8,000 hours, the maximum they can attain, they can employ, is people that will work for them within 8,000 hours. Take note, this shows the limit, the maximum they can go. So the company wants to introduce linear programming technique to ensure judicious allocation of the limited resources. So in an examination situation, you can be asked theoretical question. As a matter of fact, when you go to the study part and to the Pathfinder past question, you will see theory questions on linear programming. You can be asked, what are the usefulness or what is the usefulness of linear programming to an organization? This is one of the answers given to you, because linear programming technique will help an organization to judiciously allocate its limited resources. So as you try to solve, balance your calculations with your theoretical aspect likewise, because the exam pattern to me is coming very easy at this point in time, because you won't just see calculation all through. Yes, in most of the papers, you also see theoretical questions. So by the time you can solve this, solve that, and pull all together, definitely, you definitely cross the 50% mark that you're trusting God to get. So as you try to solve, the theoretical aspects is also very important. And as you even solve the theoretical aspect, have a good understanding of what these issues are talking about. It goes beyond solving or trying to cram things. No, it goes beyond that. Have a real life reflection of these to your daily life. You can have a mental picture of what this is talking about and try to analyze in your own way. This will help and aid understanding. Yes, beyond just trying to force yourself to get it and get it. So to solve this question now, Based on the step we highlighted, what is the first thing we have to do? Based on the first step, what is the first thing we have to do?
Identify the objective function.
Very
That
fine.
is
So for you to identify the objective function now, what will you do? You determine the contribution. You determine the contribution. For you to identify the objective function, you first of all determine the contribution. Now, based on this question, what will be your contribution for product A, B, and C? Your contribution for product A, B, and C will be what?
Product A is 36.
Okay, can you explain further, sir? How did you get that?
Okay, so that is the selling price minus the variable cost. So the selling price minus direct materials and direct labor. So that gives us, so that is 35 and 75 minus 30, 39. Direct material and direct labor will give us 39. So it will be 75 minus 39. So that is 36.
Yes, 36. And that will be the contribution for product A. For product B, it will then be what?
13. 13.
And for product C,
That's 14.
14. 14. All right, fine. Fine, that is fine. So we are going to, okay, before going further, still, let me still ask a question. Before I show the calculation, let me still ask a question. Yes. We have direct material, 24. This 24, is it kg or naira?
Naira.
Naira.
Fine,
Cost,
it is
because
naira.
it's that cost. So it's under cost.
Yes, yeah, very fine. Yes, there is a cost, then colon. Yes, cost. Even when that cost is not there, you look at the naira up, it's covering, yes, it's covering the whole values. So it shows the measurement of those values is in naira. So cost, direct material. So where I'm driving to is this. If I should spend 24 naira to produce 1 unit of product A for direct material, and direct material in the question, all products use the same type of raw material, which costs 3 naira per kg. How many kg have I used? If 1 kg,
8 kilogram.
8.
8 kilograms.
8 kg, because this is the cost to produce 1 unit of product A. Now, the cost of buying 1 kg to produce 1 unit of product A is what? 3 naira per kg. So the kg you will use to produce product A will be what? 24 naira divided by 3 naira per kg. 3 naira per kg, yes. You're going to have how many kg? 8 kg.
8 kilogram.
Yes, 8 kilogram. So these are some of the understanding you must have, because in formulating your inequality, you need the per unit value, the per unit value of each of those limited resources. So in this question, it is not given. So you need to determine that yourself. You need to determine that yourself. So in terms of labor, let's go to labor. Let's go to labor. That direct labor is this 15, 20, 30. So now all workers are paid at the rate of 2 naira 50 kobo per hour. The question now is this: if I should pay 15 naira to produce a single product of product A, and 1 hour costs 2 naira 50 kobo, how many hours will I use for product A?
6.
Hours. That is 15 naira divided by what? 2 naira 50 kobo. So same apply to this. 20 naira divided by 2 naira 50 kobo. 30 naira divided by what? 2 naira 50 kobo. So fixed overhead is what? 160% of labor cost. So if you want to get fixed overhead, though I don't think it's required here, you don't need it. But I know if you're in the exam hall, you'll be imagining, won't I use it? You understand?
160% of 15.
Yes, the fixed, yes, 160% of 15 will give you the fixed overhead. So let's see. Now the question says, make necessary calculations and formulate the linear programming objective function. Linear programming objective function. And constraints to maximize the company's contribution margin. You can see the statement. They are asked to formulate objective function, right? And constraints to maximize the company's contribution margin. So this is what the question just wants you to do. This is what the question wants you to do. So let's see how to do this now. Let's see how we treat this. Let's see how we treat this. Step 1. Step 1. Identify the contribution. Identify the contribution per unit. So we have 3 products, product A, product B, product C. Now the selling price for each of these is what? For A is 75, for B is 60, for C is 80. Contribution is selling price less variable cost. What are the variable costs? Variable cost is what? We have direct materials.
Direct labor.
And the value here is what? It's 20, 24. We have to less. The value here is what? 27. We have to less. The value here is what? 36. We have to less. Now, which other variable costs do we have? Direct labor. Direct labor. The value here is what? 15. The value here will be what? 20. The value here will be what? Will be 30. These are the variable costs we have in the question. So selling price less variable cost will give you what? Contribution. So your contribution for these will be what? 36. For these will be what? 13. For these will be what? 14. Now, these are the contribution. Now we need to determine the value of direct material used to produce each of these units. So we have direct materials per kg. Direct material per kg. How are we going to determine that? If you incur this to buy direct material to produce A, and 1 unit of direct material, according to the question, is what? 3 naira per kg. How many quantity of direct material have you purchased? 24 divided by 3 will give you what? 8 kg. And for this, it will be what? 27 divided by 3. You have what? 9 kg. And for this, it will be what? 36 divided by what? By 3. You have what? 12 kg. What else do we need to determine the direct labor? Direct labor hour per unit. Direct labor hour per unit. Now, we have what? 15 naira labor rate to produce 1 unit. 1 hour costs what? 2 naira 50 kobo. How many hours do you use to produce 1 unit of product A? 6 hours. For product B, you incur overall 20 naira and 1 hour costs what? 2 naira 50 kobo. How many hours will you incur or will you put in to produce a unit of product B? Is what? 8 hours. And for C, you incur overall 30 to produce 1 unit. 30 naira is the labor rate, and 1 hour cost what? 2 naira 50 kobo. How many hours have you put in? 12 hours. Any question based on this first step? Any question? Step 2. Step 2. The step 2 is what? Formulate the objective function. Formulate the objective function. And for you to formulate the objective function, based on these results of contribution, what will be your objective function? Your objective will be to maximize what? Contribution. To maximize contribution. Yes, to maximize contribution. That will be the objective function, because the results you have when you compute is a positive one. If you are having a loss, it will be to minimize cost. Yes, because the objective of a business is to make profit. So when you are experiencing loss, as a business manager, as a financial manager, what will be your advice to your organization? Let's look at the cost. How can we reduce the cost? So that will be minimization of cost. But when you are making profit, your objective will now be, how can we sustain this? How can we maximize this? You understand? So that is the concept. So if you are experiencing loss, you'll be looking at ways to cut down costs that are making you to experience loss in order for you to return back to your original objective of making profit. So based on these results, our objective is to maximize contribution. So the objective function will be what? Maximize what? Contribution. Maximize contribution. And what are those components of your contribution? For products A, your contribution is what? For product A.
36.
36.
So you express it in this way. 36A plus what? For B, it is what?
13B.
To be
13B.
13B. And C, it will be what? 14C. 14C. So this objective function, for you to achieve this objective, it is subject to certain limitation. It is subject to certain constraints. The question is, what are those constraints that this objective function is subject to? For you to achieve this, there are certain factors you must look at And what are those factors? They are those limited resources in the organization. So it will now be objective function is subject to what? Subject to constraints. Constraints. So you identify those constraints and express them in form of what? Inequality. Now, based on this question, even though we've identified them, I still want to ask, what are constraints?
Material and labor.
Raw material and labor.
Okay.
Material and labor.
Okay, material and labor. When I was trying to identify where the noise is coming from. So material and labor. Now, for material, in terms of product A, how many kg do you need to produce product A?
8 kg.
kg.
8 kg. So you have it this way. You said material. Material will be equal to what? Will be equal to 8A.
8A
8A
plus
for
9B.
B. Yes, plus 9B plus what? 12C.
12C.
So we have it as what? Plus 9B plus what? 12C. Now, all these, what is the maximum of material you can have based on this question?
It's 12 kg.
12,000.
So all this material cannot be greater than 12,000 kg. So it will be less than or equal to what? 12,000 kg. Less than or equal to 12,000 kg. Less than or equal to. This is the sign of less than. You know, this can be confusing. Sometimes when people will turn it the other way, they will say it is less than. So you should know when you face your left hand, you understand? It's the less than, and when it is you curve your right hand is a symbol of what?
Greater.
So in case you used to forget, look for a way to always remember. So, but when you're in an exam situation now, you can just do one drama and you think. So this is expression for material. For labor, I need somebody to express that for me. For labor, somebody should
For
express
labor,
that.
it will be 6A.
Please help
For
us
labor,
turn
it
to
will be 6A.
Labor, we
It
have
will be
it
6A
6A, yes,
plus 8B plus
yes.
12C.
So everything is subject to what?
8,000
Breakdown of
hours.
equals to 8,000 kilograms.
Less than equal to 8,000 kg.
So we have it as 6A
6,000.
plus what?
Okay,
Plus
8,000 labor
8B plus what?
plus
12C
less than or equals to 8,000
less than or equal to 8,000
hours.
hours. Now, when you formulate your constraints based on the step we highlighted, what will be the next thing? Check the steps.
Non-negativity. We express each of the constraints in the form of inequality.
Yes.
I don't know,
That is-
establish the concept of non-negativity at the end of the model formulation.
Sorry, please, can you see my screen?
Yes.
Yes, sir, we can
Yes.
see it.
I'm
What
getting
what he is, I think, what he's trying to say is that probably you should be referring back to the main question so that we'll be following the question
no, the
wise.
point is this. You can if you have you're using two devices, you can screenshots. Let me go back. You can screenshot the question because I don't have time during the day. I could have this is the question. You can just have a screenshot of it and always make reference to it. Yes. So the label
We
is
want
this. So the next step is non-negativity. You can mute yourself if you're not talking so that have less noise. Right. So non-negativity. Our discussion about non-negativity, we said what? Non-negativity. What did we say about non-negativity?
It will be greater than or equals to 0.
Was it greater than? What is that thing that was greater than? Either resources, either the product, isn't it?
Yes.
Now, in this regard, the products is what we're looking at. That you cannot produce anything less than anything negative. So the non-negativity with respect to this will be what? For product A, in some instance, you can express it as A will always be what? Greater than or equal to what? 0. Because you cannot have minus product A. You cannot produce negative product A. So it will always be greater than or equal to 0. And for product B, you can put comma. For B, it will also be B greater than or equal to what? 0. You have a comma. And for what? For C, it can also be what? Greater than or equal to what? Equal to 0. You can express it in another way by just writing A, comma, B, comma, C. All you've expressed is what? Is greater than or equal to 0. It's same interpretation. Same interpretation. Same interpretation. Going back to the question made it clear that make necessary calculation and formulate the linear programming objective function and constraints to maximize the company's contribution margin. So what you've expressed, you've shown the contribution, you've identified the objective function, which is this, and you formulated the constraints, and you've shown the non-negativity. Based on this question, this is what the question wants you to do. This is what the question wants you to come up with. So this is just to introduce this. Let's look at another question. Any question about this, please?
No, sir.
All right, that is Madam Choma. Anybody else question? So that when we go to the next one, maybe you'll be the one to teach me now. So that
Sorry, sir. So does it mean that that's how we just end the question?
very well. That is it. So that is how you end the question. For this, Yes, but we're going to another one where the question wants you to
More.
do more. Yes, we are looking at another example where the question will want you to do more. Yes. So you start with the little one, then you now go to the one that wants you to do more. So let's go to the one that will do more. Let's see. Okay, let's look at this now. Can somebody read?
Sir, please, I want to get the solution, please. Please, in
For
some
that last
minutes,
one.
please.
Where are you, sir?
Yes, I want to take this. No, the page before this one. Let me just take it. Yes, the next page, sir. I'm done with this. The next page. Thank you, sir. Done. Thank you, sir.
Somebody read out this. All right, thank you too, sir. Somebody should read.
Express Nigeria
Okay.
PLC markets two products which are produced in three successive departments. The contribution per unit of the two products and the production capacity of the three departments are as follows. We have product A and B, unit contributions in Naira. We have for A we have 6, for B we have 5. Machining department in bracket hours. For A we have 3, for B we have 4. Foundry department in hours, we have 2 and then 1. For painting department per hours, we have 4 for A, and for B we have 5. A constraint of production is that each department has a limited number of hours available for the forthcoming plan period as shown below. Departments and available hours: machining 6 hours, foundry 250, painting 720. Required: 1. Formulate linear programming problem for the above information. 2. Solve them graphically. Nice.
All right. Thank you very much, Ma. So this is more work, and we should solve them graphically. I believe we still know how to plot graph. You still know how to do your scaling, the y-axis and the x-axis. If you always frown when they talk about graph, this is not the time to frown. It's the time to love it now. Yes, you know, some people when they see graph, begin to squeeze their face. So it's something you can embrace and enjoy by plotting. So looking at this question, we have two products, A and B. If you look very clearly, we've been given contribution per unit straight away. For A is 6, for B is 5. So based on our first step, what are we to do? The question says formulate the linear programming problem for the above information. So what are we to do based on the first step that we have in our notes?
We identify the contribution per unit.
All right, the contribution per unit. So once you identify the contribution per unit, this will lead you to what?
Objective function.
The objective function. The objective function. And the objective function will now be what?
To maximize contribution.
To maximize contribution.
Positive value.
So how will you express it?
6A plus 5B.
6A plus 5B. It's just simple expression. You know, sometimes when we hear linear programming, we think it's something big, something complex. It will only be complex when you start using your system, your Excel to compute it, to solve it. So it will not even be complex because you use formulas to show the expression. Yes. But in this region, we are still using our paper to do it. So now, once you formulate the objective function, which is 6a plus 5b, the objective function will now be subject to what?
To constraints, which is machining hour, foundry hours, and painting hours
Yes.
for A
So,
and B.
yes, because the question made it clear that a constraint on production is that each department has a limited number of hours available for the forthcoming plan period as shown below. So for machining, the maximum you can have for the period that is being planned for is what? 600 hours. For foundry, the maximum you can have in that department is what? 250 hours. For painting departments, the maximum you can have is 720. So this is the limit. So where you have demand, you have supply to make that requires more hours. It means you cannot go beyond these stated hours in the question. So these are the maximum you can afford. So these are the limiting factor because there are more than one. So we use the linear programming model, yes, to see how we can maximize contribution. So now let's show them on the screen how we're going to go about it. And this, once you formulate that, we need to go further by getting the value of the unknown. Then we represent the unknown values, the known values on the graph. So let's see how we can do this. So solution. Solution. Formulation. Please hope you've taken a screenshot of the question. Let me see if my WhatsApp is open on my laptop, so I can just forward it to the. It's trying to.
But sir, let me ask you a question. Will this video be made available to us after the class?
Very well, sir.
Okay, thank you.
All right, my WhatsApp is so solution. Formulation of. So when answering question in the exam hall, always write like a professional. Make clear headings for your workings. Yes, it's a professional exam. It's not an undergraduate exam. So you're expected to write well. No matter how the question is coming, your presentation matters. Formulation of linear programming model. So the first thing is our objective function because our contribution has already been determined based on the question, which is this. For A is 6, for 5, for B is 5. So the objective function the objective function will be what? To maximize contribution. To maximize contribution. To maximize contribution. And based on the question, the contribution we have for A is 6. And that will be what? 6A plus what? For B, that will be what? That will be 5B. So I said this contribution is subject to constraints. Subject to constraints. Subject to constraints. What are those constraints? 1 for machining department is labor hours. Machining. So the question you always ask yourself when you get to this point, how many hours will I use to produce 1 unit under machining department? So for machining department, to produce 1 unit, how many hours?
3 hours.
Yes. So you can see, I've stated, once you see anything in brackets, it's very key. So this is not naira now. You understand? In the first example, the question have naira at the top. So we have to divide to get the hours and the material a unit per unit. So in this case, it's given to you directly. Says the contribution per unit of the 2 products and the production capacity of the 3 products as follows. So all these data are based on 1 unit. So machining department, to produce product A, you need how many hours for 1 unit? 3 hours. For B, you need how many hours? You need 4 hours. All these cannot go beyond what? How many hours?
600 hours.
600 hours.
600 hours. So you express machining department machining department. So we have it to produce product A per hour. You need 3 hours.
3 hours.
3A plus what?
So,
Plus
4
4
B.
B.
plus 4B
Yeah, 4B.
Less
plus
than
4B.
600.
All these will be less than or equal to what?
600 hours.
600.
Less than or equal to what? 600.
600.
600 hours. Right, 600 hours. So the next is foundry.
Foundry.
Foundry departments.
Department.
Foundry departments. To produce product A under foundry department, you need how many hours for 1 unit?
2
2
hours.
2 hours.
and 1 for B. So
For
it will
B.
be expressed as what? As
2A
2A plus
Plus
what?
plus 1B.
Plus B.
Yes. There's an invisible one behind B. So
Yeah.
just
Yes,
write B, right? It's the
yes,
same thing
yes.
as
That's
1B.
1B.
So it will be less than or equal to what? 250
250
hours.
hours.
250 hours. For painting. For painting
Painting
department,
department.
we have it as what?
4A. 4A.
For A
4A plus 5B.
5B.
will be less than equal to 720.
720 hours.
So we have it as 4A plus 5B will be less than or equal to what? 720 hours.
20 hours.
720 hours. What will be the next step?
Non-negativity.
Non-negativity. Now, the non-negativity in terms of the product will be expressed as what?
A is greater than or equal to 0.
Greater than or equal to 0. A is greater than or equal to 0. A, B is greater than. So whichever you can express in this way. Now, this is the response to the first part of the question. Now, that we should solve them, we should solve graphically. Yes, Mr. Abajide.
Okay, sir. Thank you. So now, in this question, it is very obvious that the limiting factor is labor hours.
Yes, sir.
But now, so as opposed to the other question, which has both labor hours and materials. Okay, but now, so in this case, we have just just labor. But now, that labor is now spread at the limiting factor of labor is now spread across the three different
Very
departments.
well, sir.
So how
Very
can we
well.
describe this situation? So can we still say that yes, we have more than one limiting factor?
Yes, looking at it in terms of based on departmental level.
Okay.
Yes, yes. So you can see it is being fragmented into departments. Yes. Looking at departments, machining department, foundry department, painting department. So we have limitations in each of these departments in terms of labor hours. So how do we pull them together? And how do we maximize contribution from each of these? So to solve them graphically, what are we going to do based on the step? Go back to that step. To solve graphically, what are we going to do? If you put it down, if you don't put it down, let's go there. For you to solve graphically, you must do something, right? What is that thing? So I want to hear.
You have to convert the linear to simple equation.
Yes, you need to convert the inequality into what?
Simple
Into
equation.
linear or simple equation. So when you come back here, these inequalities, you convert them into what? Equation. How do you convert them into equation? It's just by changing the inequality signs into what? Equal signs.
Equality sign.
So we have it. So change this to what? To equal sign. Change this to equal sign. So now, for you to solve graphically, we have three equations here. Three equations. We have machining department, foundry department, painting department. So to solve graphically, machining. Machining departments. We have this equation 3a plus what? 4b equal to what? 600. You know, on a graph, you have two axes, right? You have x-axis, y-axis. You can have a-axis, b-axis, depending on how you want to define your graph. But definitely, there will be two axes. meeting at a point, the point of origin. So now, for you to plot on a graph, you must get two variables. Variables on the x-axis and on the y-axis, or variables on a-axis and the b-axis, depending on how you want to label your graph. So now, for machining department, A is unknown. How are we going to get the value of A? How are we going to get the value of A? We can get the value of A by saying let B be equal to what? 0. If B is equal to 0, what is A? If B is equal to 0, what is A? This is it. 3A plus what? 4. I just want to show it very clearly so that I won't get questioned as much. If B is 0, you replace B with 0. 4 times 0 will give you what?
0.
Zero.
4 times 0 will give you 0. So we have it. I will show it step by step. So we have 0 here equal to what? 600.
600.
So you collect like times. If 0 should cross to this other side, you know it's having a positive sign here. To change to what?
Minus 0, which is the same thing as 600.
Very fine. So we now have 3A standing alone equal to what?
600.
600 minus 0. I'm just showing it. I'm not supposed to be showing this. But I know we might not be on the same pedestal. So let me show it. So we have it. We now have it as 3A equal to what? 600. Because 600 minus 0 is what? 600. So you divide both sides by what? By 3. So that only A will remain on its own. Divide both sides by 3. So that you just have only A remaining on its own. So we have it like this. We have it in this. So when 3 cancel 3 at this point, what will you have left?
200. 0. Or
So
1.
A will be
So we
what?
have A
Equal to what?
equal
A will be equal to what?
200.
200.
200.
200.
So for you to solve for, you have the value of A now. So let me just write it. When B is equal to 0, A is equal to what?
200.
So for you to get the value of B now, you will now say, let A be equal to what? 0.
0.
When A is 0, what is B? Can you solve? Or I should still solve it.
It's 150.
So B will be what? 150. If you don't know how we get 150, speak out now. Let me still show it. I will still show it. I will still show this.
How did you get it, sir?
Okay. Okay, thank you, sir. Thank you for speaking out. Let me show it. Let me show it still. But I know Mr. Abajide should know how we arrive at that. But let me show it. So now, when A is equal to 0, what is B? Question mark. What is B? So I will now say that 3 into the bracket of what? 0, replacing A with 0 because A is assumed to be 0, plus what? 4B equal to what? 600. 3 times 0. 3 times 0 is what?
0.
Don't mind me. I need to ask. Yes. So let me ask another question. Anything raised to the power of 0 is what?
It's 1.
Because when we start doing pricing decision and we look at some little element of differentiation, and I'm asking anything raised to the power of 0, somebody can tell me is 0. So anything raised to the power of 0 is what?
One.
Is 1. Yes. So now 3 times 0 is 0. So we have 4b equal to what? 600. So we now have, for us to get the value of b, what are we going to do? You collect like times. I'm just showing all this primary school thing.
We make this
I'm not
a bit
supposed to
of
be
the
showing it.
formula. We
Collect
make
like time. To now be
604.
4b equal to what? 600. 0 cross to the other side. If it's positive currently, it will be what? Negative. So we now have it as what? 4b equal to what? 600 minus 0. 600. Then it will now be what? For you to get the value of b, you divide both sides by what? By 4. Divide both sides by 4. And you divide both sides by 4. Straight. 4 will cancel each other at this point. When this 4 cancel this 4, you are left with only b. So it will now be b equal to what? 600 divided by what? 400. So 600 divided by 400 will give us what?
150.
150.
150. So this is how we derive 150, sir.
Okay, sir. Thank you.
Thank you too, sir. So now, for 400 departments, people should solve. Give me the value of A and B. For 400 departments, solve. Oh, don't solve. If you know you didn't get it, tell me. Let me show you the workings. Don't just burn your data and don't understand what we are doing. So for 100 departments, the value of A will be what? If B is 0, what is A?
A is 125.
A is 1.
Yeah, A is 125.
Very good, 125. So what will be the value of B?
250.
The value of B will be 250. If you know you are not getting 125 and 250, raise up your hand. I will show it. Don't worry, I will show it. I will still show you the steps. If you know you are not getting it, so you can just follow this step. Let me give you some minutes, seconds like that. So if you know you are not getting it, let me know. Because when you go to the Pathfinder, there is nothing special. It's still all these steps you see. They will not even show these steps. They'll just give you the answers. They will not show it. It's not left for you to know how it was derived. So, are we good to go?
Yes, sir.
So let me write it. So I'll just write the value of A and B for 400. 400 departments. 400 departments. The equation is what? 2A plus what? Plus B equals what? 250. So if A is equal to 0, B is equal to what? 250. If B is equal to 0, A is equal to what? 125.
125.
For painting departments, for painting departments, for painting departments, the equation is what? 4A plus what?
5B.
Plus 5B equal to what? 720.
724.
So if A is equal to 0, B will be equal to what? 140.
144.
If B is equal to 0,
A will be
A will be equal to what?
44.
180. 180.
A will be equal to 180. A will be equal to 180. So with these results, can we plot on a graph? With these results, can we plot on a graph?
Yes. We can start.
So you can have A axis and B axis, right?
Yes, sir.
A axis and B axis. Then based on the figures you have, you can look what is the appropriate scaling I can give. You have 250, 125, 144, which is the least and which is the highest value from the results we have. Then so that it will determine our scale. You have 200, 150. We have
125 is
250,
the least.
250 is the highest.
144. So you can have a scaling ranging from 50, 100, 150, 200, 250, 300, interval of 50, depending. You can have a scaling of interval of 100, 100, 200, 300. Yes. If me and you we are solving in the hall, our scaling will not be the same. Yes, because I'm not seeing what you are doing. You are not seeing what I'm doing. So the major thing is follow the principle and get a very good curve. Yes, plot a very good curve that once I'm trying to interpret, okay, A is 250 here for 400 departments. A is 125 for 400 department. Definitely, I should trace my line to B where I will get what? 250. 250. So that is the concept. So the graph should not be something complex. I don't have a written pen, so but I think I have the sketch of how the graph should look like. I'll use that to explain. Let me see. I think I have a better graph one time. Let me see. This is the graph I have here is not correct. But I know I have another one I drew one time. Okay. Anyway, let me just use this graph to explain. You can plot a better one. You can plot a better one. So this is a graph. We have the A axis, we have the B axis. So you can have your scaling. You can draw your own. Even as we are talking, you can plot your own now. Yes, you can plot your own. So you can have a scaling of 50, 100, 150, 200, 250, 300, like that. On the A axis, on the B axis, 50, 100, 150, 200, 250, 300, 350, like that. Now, looking at what you have in your book, at this point of intersection, this is the origin here, the origin of this graph. So now, from your question, from your solution, for foundry department, for foundry, or which is the first one now, machining, For machining department, for machining, B is what? When B is 150, what is 200? When B is 150, what is A? A is 200, right? For machining. So you locate at point B. Where is 150 at point B? On your own graph. This graph is not correct. I can't locate this slide. I have a correct graph. So, but the issue is for machining at point B, machining we have 150. Then at point A, it is what? At point A, it is what?
200.
200. So if this is 150, if this point is 150, I should trace 200 to point A for machining. So you use your ruler to connect these lines. You just put asterisk here, then you use a very good ruler to connect those 2 points and draw a straight line across. So that is for machining. Then for foundry, if B is 250, this is B axis. If B is 250 here, if B is 250, what is A? What is A? If B is 250,
125.
so I should have a line, an asterisk here, and my 125 should be within this region, this middle point here. So once I connect 250 to 125, I draw the line across. Sorry, my image is looking somehow. Okay, fine. So the next one is painting department. For painting department, B is what? 144. 144 should be within this region. 144. For painting, B is 144, right? What is the value of A for painting?
180.
So you should have 180 at this point here. So when you connect the two lines, they should meet. 144 to 180. These two lines should what? Connect. They should connect. So when they connect, you now locate on the graph the boundaries that connect. The boundaries that connect. That's from this midpoint here, to the highest here, to the first line here. What are the lines that connect this region? So when you are solving, when you plot your graph, you just locate from the midpoint here to the highest point here, this region here. What are those lines that connect? You need to locate them. We have a point here, and we have what? A point here. In some graphs, you can have more than 3 points. You can have another line that will connect here. You also identify that. So you can have A on this point, B on this point, C on this point. It can be X, Y, Z, depending on how you label it. It must not be the same thing with everybody. So this region, from this midpoint here to the first line here, the highest point here, they are the visible region. The visible region. And when we talk about the visible region, what are we referring to? The visible region. Though mentioned that before. The visible region. The visible region. This visible region is very important. You'll be asked to locate that on a graph. This visible region is the shaded region on the graph that represents what? All possible combinations of decision variables that satisfy what? The limitations, the inequalities.
Come again, sir, please, sir.
All right. So this visible region here the visible region, it is the point of what? Of constraints, where we have limitations. Anything outside this point, it means you have the resources in excess. This region is not bounded by limitation. But this visible region, what are the coordinates on it that make up the visible region? The coordinate that make up the visible region is this point here of intersection, this point of intersection, this point of intersection. So I said the visible region is the shaded region on the graph. So once you identify the visible region, you can just shade that portion. You can just shade it, or you give a mark, you can put star, 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 star. You know how you can shade, or just to recognize that this is the visible region. And I said that it is the region that represents all possible combinations of decision variable in which all inequalities are satisfied. So this point, when you connect them together, they serve as the visible region on a graph. The visible region on a graph. So this visible region is the bounded area, is the region of constraints, because in a question they will say, using the graph, identify the constraints. Now, in one of the most recent questions on linear programming, where we have skilled and unskilled, we have labor hours, we have about 4 constraints, and we are asked to plot those things on a graph. So most times when students plot, they don't plot appropriately. They will now determine another resource as the limitation. But if you plot the graph very well, the 2 constraints based on the graph will, I'll refer you to the question. So those regions that are bounded, the closed area, they are the visible region. While this region that extends, the unbounded area, they are not bounded by constraints. They are not binded by constraints. Yes, another word they use is the binding constraints region. The binding constraint region. So this region, the visible region, is the area that is bounded by limitation. That represents the all non-negative solutions. That is, this region, it shows the region of what? Of constraints. That there is limitation. If I'm to produce within this region, there's limitation of hours within this region. So once you identify this in your graph, what else can you do? What else will you do? Now, on this graph, you will note something. Within this region, 2 lines are intersecting. 2 lines. We have 2 department where we have intersections. And that point, I put B here, point B. And what are those two departments where we have intersection? The two lines, you should be able to identify them. Foundry and what? And painting. This point here. This point of intersection. We have another intersection. We are not concerned about it because this is outside the visible region. It is the two lines of intersection that form the visible region that we are concerned about. So this point B, what are the two departments that intercept at this point? What are those two departments? When you trace it, foundry and what? And painting departments. Foundry and painting department. They are the two lines that intercept at that point. Somebody wants to ask a question? So now, why this graph? Why this graph? We can use this graph to determine the optimal mix. Based on our knowledge of limiting factor, what is optimal mix? Optimal mix. Based on our knowledge of limiting factor, what is optimal mix? Any idea? Optimal mix. I said in one of our classes.
It's a mixer. It's a mixer had the highest.
Okay, very good. Yes. So optimal mix refers to the best combination of products or activities that maximizes contribution or profit. Or it can be a mix of products or activities that minimize cost. So when we're solving limiting factor, I was saying that when you have a resource,
Please, sorry, sir. Excuse, please. Can you please come again, please?
I said optimal mix refers to the best combination of products or activities that maximizes profits or contribution. Or minimize costs. So in limiting factor, I said that when you have 8,000 hours for the production of product A, product B, product C, the total unit you can produce using 8,000 hours will serve as what? The product mix. If you have 2,000 hours, the total unit you can produce using 2,000 hours will serve as what? The product mix. So when you want to now compare all this mix, which is giving you the highest, you can now come up with that. This product will give us the highest optimal mix. And once it's giving you the highest optimal mix, it means it will give you the highest what? Contribution. To give you the highest contribution. So if you reflect back to limiting factor, you discover that the first rank product will be satisfied with the limited resources. Hence, you will have to sell more of it. And that will result in more contribution from that product. So it shows that the product that have the highest output will result into the highest optimal mix based on ranking in terms of limiting factor. Now, in relation to this linear programming, you will be required to determine optimal product mix likewise. The optimal product mix. The optimal product mix. And for you to derive the optimal product mix, you need to know what the total contribution is. Now, we have 3 points on the graph in terms of the visible region, point A, point B, point C. Now, the question is, what is the total contribution at point A? What is the total contribution at point B? What is the total contribution at point what? At point C. So how are we going to know that? Can I get an idea? For you to know the total contribution at point A, at point B, at point C, what will happen? You need to go and pick your objective function. The objective function when we started solving this question is what? The objective function. What is that simple expression?
To maximize contribution.
Yes, so what is the expression, sir?
6A plus 5B.
Yes,
6A plus 5B.
So 6A plus 5B. We'll use that 6A plus 5B to formulate a table, a solution table. It is that 6A plus 5B we'll use to determine what the contribution is at point A, what the contribution is at point B, what the contribution is at point what? At point C. We'll use that. So the question will now be, at point A, all right, ma?
Yes, sir. I don't know whether it's my phone. I can't see the point. I'm not seeing the cursor. Where is point A or B and
Same
C
here,
located?
This is it. This is point A, 150 here, sir. Oma. Point B, this point here, this cursor, this intersection point. Point
Okay.
C, this point here of 150.
Okay.
So we use these points, the contribution, to determine the total contribution at this point, the total contribution at this point, the total contribution at this point. But take note, I said there is issue with my graph anyway, but still we can solve. So we have a solution table to determine the total contribution on each of those points. So we refer back to our contribution. Solution table. So the solution table will be in this form. Solution table. We have points. We have points. On the graph, we have point what? Point A. Point what? Point B. We have point C. Now, our contribution is what? We have 6A plus what? Plus 5B. Then our total contribution on each of those points will now be what? Total contribution on each of those points. Now, at point A, at point A, what is the value at point A? This line here, 125, right?
Yes.
Very good, 125 at point A. So it will be what? 6. If A is 125, it will be 6 into the bracket of 125 plus what? At that point, B will be 0. because we want to just know the total contribution at point what? At point A. So it will be 5 into the bracket of what? 0. So what will be the total contribution at point A? The total contribution at point A will be what? 6 multiplied by 125.
750.
750. At point B, something is happening here. We have 2 lines of intersection, isn't it? At point B, 2 lines of intersection. So what are those 2 lines? You must identify them. What are those 2 lines? Yes, I need a response so that I will know you are getting it.
As foundry and painting, right?
Foundry and painting.
The departments, yeah.
Foundry and painting department. Fine. So we need to go and look for those equations that make up foundry and painting department. Those two equations. Let's just take note of that. Let's quickly treat for C. Let's quickly treat for C because so that we'll go and do the workings for B. At point C, the value at point C is what? The value at point C, though this is not correct, there is a value at point C that is painting. What is that value at point C? Painting, that is B, 144. 144. Yes, C is 144. So the total contribution at point C will be, at this point, 6 will be what? Multiplied by what? 6 will be multiplied by what?
140.
By
By
0.
0.
Zero.
Then here, it will now be 5 multiplied by what? 144.
Okay.
So what will you have here?
720.
720. Let's go back to B, where the work is. Because we have 2 lines of intersection, what are those equations that form this intersection? Let's determine them. What are those 2 equations that form the intersection? We said foundry, right? Foundry and painting. So foundry, the equation is what? Foundry, the equation is
2A plus B.
2A plus B. 2A plus B is equal to what?
250 hours.
And the other line is what? Painting.
4A plus
4A
5B.
plus 5B is equal
Equals
to what?
720 hours.
720. Those days in secondary school, when solving a simultaneous equation, they used to tell us there are about 3 approaches, right? We have substitution method, we have elimination method, we have the almighty formula. So when you try to solve this, we are going to solve by trying to eliminate one of the variables. Yes. So this will be equation 1. This will be equation 1. And this will be equation 2. This will be equation 2. Now, what do we need to do? We need to look for a value that we can multiply by equation 1. And we'll look for a value that we can multiply by equation 2, that one of these will be the same. So we want to get, first, we want to get the value of B. We want to get the value of B in this equation. So what can I multiply by equation 1 and multiply by equation 2 that I will eliminate A, these two A's here? So you can multiply equation 1 by
two.
what?
By
By
two.
2.
By 2. So it will become 4A.
Multiply
4A. The
equation
second
2
one will be multiplied by 1.
by 1.
By 1. By 1.
So foundry will be equal to us 2 times 2A,
4A.
4A, plus 2 multiplied by B, 2B,
Will be
equal to
2B.
2 multiplied by 250 is what?
500.
Will
500.
be 500.
For painting, 1 multiplied by 4A,
4A,
4A.
4A
1
plus
multiplied by
5B
5B,
5B,
1
equals to
multiplied by
720.
720. So
720.
when you put a minus, those times they will put one minus here.
Just please 4A. 4A.
We'll put one minus here like this. We'll now rule a line and minus. So this would be what? 0. Okay, yes. So 5B minus 2B will give you what?
That's minus 3B. And that's 3B.
3B.
720 minus 500 will give you what?
120. 220.
220.
220.
The value of B can be what?
8B.
220 divided by 3.
Yes.
73.
That's 73.33.
That's
73.33.
For you to get the value of A, what will happen now?
Substitute.
We'll substitute B into any of the
Equations.
Okay, all right, fine. So for us to get the value of A, let's substitute B into foundry, into equation 1. Let's see. F will be equal to 2A plus what? 73.33
73.33
equal to what?
250.
50. So the value of A will now be what? 2A equal to what?
250 minus 73.33.
The result will now be what? F is equal to what?
2A. F is equal to 176.67 divided by 2, which is 88.34.
176.67. So I divide both sides by 2.
By 2, yeah.
It will give you, F will just be what? I'm jumping steps.
88.34.
88.34. Fine. So you now have the value of sorry, this should be A. You now have the value of A and B, right?
Yeah.
You have the value of A and B. You can now come back to this table. At this point, it will now be what? 6A. 6 multiplied by what? The value of A is what? From the equation you saw.
88.34.
It's 8.34.
Yeah.
Plus 5. The value of B is what?
73.33.
So when you do the multiplication and the addition, what will you have as total contribution?
896.69. 96.69.
896.69. 896.69. It 96.69. So if you are asked, what is the optimal product mix? At what point do you have the best? At what point do you have the best?
Point B.
Point B.
Because we have the highest contribution at that point. We have the highest contribution at that point. So when you plot a graph, and the question wants you to determine the optimal product mix, the question wants to determine the total contribution on each of the points, you prepare a solution table in this form. In this form. There is more to this when we talk about the concept of shadow price. The concept of shadow price. And what is this shadow price? Shadow price is just the extra benefits, the additional benefits that you will derive when you add one more unit of that scarce resource to that equation. For example, I'm just introducing it. In the next class, we'll talk about it in detail and solve the question. For example, if I want to compute shadow price, from the definition of shadow price, we said is the extra contribution, extra benefit that you will get when you add one more unit of the scarce resources. So if I should add 1 hour to 600 hours, the result will be what? 601. If I now solve again, what will be the increase in contribution that will result as a result of the addition of this one? That is what the concept of shadow price is all about. Once I treat this in relation to these equations, I can now also determine if I should add one more hour to 400 departments. I'm with you, sir.
Okay. Sir, you can recap that, sir.
Right. Just introducing this. All right. So talking about shadow price, I'm just saying that the terms can look as if they are complex, but in solving they are not. Shadow price, I said, this is the extra contribution you will get when you add one more unit of the limited resources. We said hours are limited in the various departments. If I should add 1 hour to these 600 hours, what will be the extra gain? What will be the extra contribution? What will be the extra benefit that this 1 hour will bring to this department? So the difference between the new contribution and the old contribution will give me what? My shadow price for machining department. If I should add 1 to this 250, I now solve what will be the difference between the addition of 1, that is the new contribution, and the old contribution without this addition of 1. So that is what the concept of shadow price is talking about. So there are various methods in which we calculate shadow price. There is the simple arithmetic method, and then there is the graphical solution method. So what we do from the question analysis, the concept of the simplest arithmetic method, the dual method where you add 1, just as I'm showing now, is what is being used in most of the questions. So in the next class, I'm going to dwell more on this, and we'll solve a question on shadow price. But before we go, based on what we've discussed tonight, any question before I share the assignment? Any question? Let's see.
So, and sir.
I'm with you, sir.
Oh, okay. So this is personal. So this is personal to me. So now I got most of the steps, but I got somehow confused at the point of at the point when you were plotting the table. But I will still so once the recording drops, I will still have to take my time to watch it so that I can fully understand it. And then maybe it's because I don't want to say that I'm deficient in mathematics. So I will just take my time to watch the video once again and try to attempt the assignment. Thank you.
All right. Thank you for that. I like that that approach. Yes. You have to watch it again. Yes, you have to be intentional to watch it again for the understanding to rest well with you. But in case you watch it again and you are not still clear, please don't hesitate to reach out. I will definitely create time to see. Even now, I'm very much busy. To the next 6 weeks, I'll be very much busy, but I'll still create time. I'll still definitely create time. Yes. Please do well to watch it again, and you can also always reach out. If I have the time, I'll schedule a time. If I'm very much busy, I'll schedule a time to speak with you. We'll speak about that. We'll talk about that together. Yes. So thank you for speaking out, sir. So I'm trying to get the assignments. I think I have a question in this slide. I have a question in this slide. Okay. I'm not seeing the question here. Okay. All right. I don't want to send the complex question for now. Okay. All right. Let me see what I will do. I will share the question now on the platform. I'll share the question on the platform so that we can attempt. So we'll meet on Saturday again. We meet on Saturday again for performance management. Performance management. So thank you very much for your time.
Thank you, sir.
Thank you. Thank you very much.
Thank you.
Really appreciate your time.
Sir.
Thank you, sir.
You are welcome.
Thank you,
Thank
sir.
So, Madam Victoria, I can see your question in the limiting factor. I will create time to look at that. Yes.
Okay, sir. Thank you, sir.
I didn't forget. I don't want to refer you to the video on my YouTube. I don't think that video is very clear. The write-up is very clear. Though I've talked about that question before, but I don't think the visuals in that video is not clear. So I don't want to refer you to it.